Next up is our wetlands workshop, and this is a presentation on the definition and delineation of wetlands in the coastal zone. And Dr. Lori Cotine and Dr. John Dixon will be making this presentation today.
Thank you. As the Commission's ecologists, Dr. Dixon, Dr. Engel, Dr. Garsky-Garcia, and I are responsible for evaluating the wetland delineations that are provided to us by applicants to ensure that they are based on the Coastal Act and the Commission's regulations, that standard field methods, which are developed and updated by the Army Corps of Engineers, have been employed, that the requisite data have been collected, and that the delineated wetland boundaries accurately reflect those data. Based on these technical evaluations, we make recommendations to the Commission. The purpose of my presentation today is to provide the Commission and the public with an overview of technical wetland delineation in the coastal zone, an appreciation of just a few of the complexities involved, and there are many, and an understanding of the basis upon which we conduct our evaluations. This talk will cover several topics. First, I will define what a wetland is and give a general overview of the wetland delineation approach. Wetland delineation involves examination of three parameters to determine if they conform to the definition of a wetland, each of which I will discuss at length. The first of these is the vegetation parameter. Second is the soils parameter. Third is the hydrology parameter. Lastly, I will go over a couple of permits that have presented challenges in the past and discuss how these challenges have been resolved. But before we proceed much further, let's be clear about what is meant when we talk about a wetland. Wetlands are lands that occur in the zone between terrestrial and aquatic systems where the water table is usually at or near the surface, or the land is covered by shallow water. So not a lake or a river or a bay, but the land that marks the zone between the main body of water and predominantly dry upland areas. In the language of wetland delineation, any area that is not a wetland is referred to as an upland. To flesh out this concept further, I refer you as well to the Army Corps of Engineers definition of a wetland. The Army Corps of Engineers is the agency that has developed the standardized methodology for delineating a wetland used by most government agencies, including the Coastal Commission. They define wetlands as the following: those areas that are inundated or saturated by surface or groundwater at a frequency and duration sufficient to support, and that under normal circumstances do support, a prevalence of vegetation typically adapted for life in saturated soil conditions. Wetlands generally include swamps, marshes, tidal lagoons, bogs, and similar areas. Okay. It is important to emphasize that an excess of water controls the biological and non-biological characteristics of wetlands, even though water is frequently not present in a wetland at the time of observation. In fact, wetlands can often be identified because the physical and chemical features of the soils differ from upland soils, and because the types and abundance of plants, animals, and soil microbes that occur in wetlands are often quite different from non-wetland areas. Wetlands are important because they provide many ecosystem services of importance to humans. For example, wetlands provide habitat for many species, including many threatened and endangered species, and typically support high biodiversity. There are many different wetland types, with each inhabited by a different complex of species. Along the coast, wetlands support coastal food webs by providing nurseries for some fish species and refugia for others. Many of the fish and shellfish wetlands support are important coastal fisheries or are consumed by coastal fisheries of significance to the California economy. Wetlands also provide essential habitat to migratory birds that traverse the coast along the Pacific Flyway. In part because of their importance to wildlife and the inherent beauty of wetland landscapes, wetlands also attract people. Californians love to spend time in and around wetlands and associated waterways up and down the coast. Wetlands filter chemicals and sediment from runoff before it enters waterways, which improves water quality for drinking and improves the health of our ecosystems. Wetlands can also be important locations for carbon sequestration, thus helping to slow the rate of climate change. Wetland vegetation also provides many important buffering functions. Intact wetlands can slow the velocity of rushing stormwater. This buffering both reduces erosion and promotes the slow percolation of water into porous soils, recharging groundwater aquifers. The recent drought reminds us just how important groundwater recharge is to California's water supply and the importance of wetlands in providing this ecosystem service. Wetland buffering is also an especially important wetland function in light of sea level rise and climate change more generally. Climate change models currently project more frequent large El Niño events with associated storm surge and flooding, such as the one that occurred this year. Under these circumstances, coastal storms can hammer the coast, eroding coastal bluffs and beaches, damaging coastal infrastructure, and impacting coastal fisheries. Where wetlands exist and are maintained, these impacts will be substantially muted. Further, if connectivity is maintained or restored between upstream freshwater sources and coastal wetlands, wetlands can accrete sediment and in part counter the effects of sea level rise. Also salient is the history of decline of wetlands in California, which by many estimates may have been reduced by 90%. Further, many remaining coastal wetlands that have not been filled in or destroyed have been impaired and are no longer functioning in a way that maximizes their environmental utility. I'll now move to discussing the general wetland delineation approach. The U.S. Army Corps of Engineers has developed a systematic, quantitative, technical approach to identifying wetlands. The method relies on identifying whether or not a piece of land exhibits specific wetland-related features so that the boundaries of that wetland may be delineated. These features, called parameters, must be hydric or indicative of wetland hydrology. Wetland delineation is an art as well as a science, in part because no two wetlands are alike. As you can see from these ecosystems, some wetlands exhibit a clear gradient from where open waters reside, or did reside in a wetter season, to uplands, but others are less obvious. The aim is to define the line where wetlands begin and end, and to distinguish them from upland areas. Wetland delineation literally is drawing a line. In this vernal pool ecosystem, the line between wetland and upland is fairly distinct at this time of year. It appears to follow the edge of the visible flowers. Along this floodplain, the wetland boundary also appears fairly evident, although less distinct than in the vernal pool example. In other ecosystems, it can be much less visible, especially if delineators visit a site at a dry time of year. To give an example of a typical wetland delineation, analysts and biologists are frequently confronted with situations such as this one. Development is proposed on a lot that borders a pond. The local coastal plan requires a 100-foot wetland buffer, but it's not clear exactly where the wetland ends without a formal delineation. It may follow this line, or this one, or this one. If it is determined the wetland ends where the red line is located, the development would not encroach into the wetland buffer. However, if the green or turquoise line demarcates the wetland boundary, the development would interfere with the wetland buffer and will need to be moved to ensure proper wetland protection. Now I'm going to turn to a broader discussion of wetland delineation. The 1987 Army Corps Manual is the current federal delineation manual used in the Clean Water Act Section 404 regulatory program for identification and delineation of wetlands. It details the procedure that the Coastal Commission follows. This manual presents the technical guidelines for identifying wetlands and distinguishing them from aquatic habitats and other non-wetlands. It provides the methods for applying the technical guidelines, and it provides supporting information useful in applying the technical guidelines. Regional guidance is provided by the Corps' regional supplements. The primary parameter upon which all wetland characteristics depend is wetland hydrology, that is, an excess of water. The secondary parameters are wetland vegetation or hydrophytic vegetation, also referred to as hydrophytes, and wetland soils or hydric soils. Although the delineation process is standardized, differences in the criteria that constitute a wetland do differ. Whereas some federal agencies require the presence of all three wetland parameters in order to identify a wetland, the Coastal Act and the Commission's regulations only require the presence of one of the three parameters. This one parameter definition is also shared by the U.S. Fish and Wildlife Service and the California Fish and Game Commission. For this reason, depending on the agency involved, wetlands are commonly referred to as three-parameter and one-parameter wetlands. Now, having stated that the Coastal Commission and some other agencies have a one-parameter definition of a wetland, I'm going to go through the specific language of that one-parameter wetland definition as described in the Coastal Commission regulations, where we see that these parameters are not all given equal weight. The statute states, wetlands shall be defined as land where the water table is at, near, or above the land surface long enough to promote the formation of hydric soils or to support the growth of hydrophytes. Here we have the hydric soil parameter and the wetland vegetation parameter. The regulation goes on to state, and shall also include those types of wetlands where vegetation is lacking and soil is poorly developed or absent as a result of, and here's where the definition becomes really specific. Frequent and drastic fluctuations of surface water levels, wave action, water flow, turbidity, or high concentrations of salts or other substances in the substrate. It goes on to say, such wetlands can be recognized by the presence of surface water or saturated substrate at some time during each year, and their location within or adjacent to vegetated wetlands or deep water habitats. And here is the hydrology parameter. So to paraphrase, if there is no wetland vegetation and there are no hydric soils, but there are other criteria indicative of wetland hydrology, a parcel of land can still be considered a wetland if the absence of vegetation and soils can be attributed to the very specific causes I outlined here. To further illustrate this point, here is an example of a one-parameter wetland determined as such by the hydrology parameter alone. The salt pan on the left at Santa Lea Lagoon does not support hydrophytic vegetation or hydric soils due to high concentrations of salts resulting from regular tidal inundation. But it is clearly a wetland due to the saturated soils, frequent fluctuation of water levels, and its proximity to vegetated wetlands and deep water habitat. Because the conditions that preclude hydrophytic vegetation and hydric soils from forming are specifically detailed in the Coastal Commission regulations, the hydrology parameter alone can confirm the presence of a wetland. In contrast, the mud puddle on the right, although it may be a fun place to play and it may meet the hydrology parameter criteria, it is not a Coastal Commission wetland because the absence of hydrophytic vegetation and soils cannot be attributed to any of the specified environmental causes in the Commission regulations. I've now covered the three parameters. Parameter is one of the terms I want to stick in your brain because it underpins wetland delineation. In the context of wetland delineation, a feature of the defined wetland parameters that is crucial to appreciate is that parameters cannot be directly observed in the field during one or even several site visits. Another term I want you to remember is indicators. These are the environmental or landscape features observed in the field. Successfully identifying wetland parameters in nature relies on the use of field indicators. Field indicators are physical, chemical, or biological features of an area that can be easily observed or assayed. Wetland field indicators provide the basis for inferring the presence of wetland parameters and are the essential tools of the wetland delineator. On this slide are some examples of field indicators, which I will explain in more depth as I go along. Unlike parameters, which are either present or not, the field indicators of those parameters may be more challenging to identify. For example, some field indicators may be created by more than one causal process. Other indicators may be ephemeral or may be masked by particular environmental conditions. Therefore, it is possible for the untrained eye to assume that a wetland does not exist simply because no obvious field indicators are present at that time. Conversely, a layperson might assume the presence of a wetland based on a field indicator that is actually an outlier or an anomaly. Although many wetland delineations are straightforward, many others require additional sleuthing. Repeated visits to a site or visits timed to correspond with spring flowering for proper species identification may be necessary. Additional media can also be helpful in making a conclusive decision about the presence or absence of a wetland, such as aerial photos, chronological photo documentation on Google Earth, or land use histories. The procedures for wetland classification are also defined in shorthand on the wetland delineation data form, which appears here. I will go into this form in more detail as the talk progresses, but for now, the basic outline of the form allows the delineator to gather evidence for determining the presence or absence of wetlands. The data form is 2 pages. At the top is some basic descriptive information of the site. Followed by sections dealing with each parameter. Within the soil and hydrology parameters, one can find the checklist for field indicators. In addition to the 1987 manual, the definition of a wetland requires the consideration of different factors depending on soils and climate in different ecological regions. The regional supplements are periodically updated by the Army Corps to reflect nuances specific to each region. 2 of the regional supplements cover the California coastal zone. They are the Arid West Regional Supplement, which applies to most of coastal California and includes those portions of the state with a Mediterranean-type climate. The Western Mountains, Valleys, and Coastal Regional Supplement addresses areas of Northern California with higher rainfall and generally cooler temperatures. Now we will talk about each of the 3 parameters individually. I will start with the vegetation parameter. Wetland or hydric vegetation differs from upland vegetation in several important ways that allow for the identification of wetlands. Many plants cannot tolerate repeated periods of saturation or fluctuations in water levels. When prolonged wetting occurs, the root system is starved of oxygen. Sustained oxygen deprivation is intolerable for many species. Similarly, many plants are not adapted to the saline or brackish conditions found in marine-influenced ecosystems. In short, plants lacking morphological, physiological, and/or reproductive adaptations to wetland conditions cannot grow, effectively compete, reproduce, or persist in areas that are subject to prolonged inundation or saturated soil conditions. So how do we evaluate whether or not the plants in a given location are wetland plants? Luckily, all plants have been classified according to how likely they are to be found in a wetland. There are 5 classifications ranging from obligate, which are plants that almost always occur in wetlands, to upland, or plants that almost never occur in a wetland. In between are facultative wetland, colloquially referred to as fac-wet, facultative, or fac, and facultative upland, or fac-up, with each category indicating a plant progressively less likely to occur in a wetland. Now, to orient you with some photos of plants you may be familiar with, here are some examples of obligate wetland species. Common cordgrass is on the left, and California bulrush is on the right. The presence of these species essentially guarantees the presence of a wetland. Here are examples of facultative wetland species, or species that are found in wetlands approximately 2/3 of the time. They are umbrella sedge and spreading rush. Here are two somewhat common facultative species. We have another sedge on the left and western larkspur on the right. These species are adapted to live in both wetlands and some upland habitats under certain conditions. And at the other end of the hydric spectrum are upland species. Two familiar species here are coyote brush and California sage. These species cannot tolerate wetland conditions and are rarely, if ever, found in them. Operationally, the delineator identifies plants in the location of the land under investigation and estimates the percent cover of each species. Plants are identified within every plant layer, starting with the tree layer and progressing to the shrub, herbaceous, and vine layers, with guidelines provided for the size of the area to be investigated for each layer. In this example involving the grass herb layer, you can see there are 5 species that occupy the area under investigation. In practice, the species are rarely found in such discrete patches. However, for the purpose of illustration, I have drawn them this way. Once all the species present have been recorded, the delineator classifies each species using a comprehensive plant list prepared by the Army Corps of Engineers. In this list, plants are classified along the hydric spectrum, ranging from obligate wetland to upland. On the wetland sheet, there are spaces for listing the species found in their classifications and the relative plant cover under each layer. However, it is not enough that hydric vegetation is present. A prevalence of hydric vegetation must be present in order to determine whether or not the vegetation parameter is met. Therefore, only the dominant species are considered in making this determination, and dominance is relegated based on the 50-20 rule. For the 50-20 rule, the actual ground cover of each species is estimated, and the species are ranked in descending order of the relative percent cover. When added together, the species that cumulatively exceed 50% of the total cover are designated dominants, as are any other species that have at least 20% relative cover. Once we have determined which species are dominant, we are still not done. We must determine if the vegetation parameter has been met. Wetland vegetation is first assessed using the dominance index. According to the dominance index, there is a predominance of hydrophytes if more than 50% of the dominant species are classified as facultative, facultative wetland, or obligate. If we consider the previous example and assign a classification to each of the 3 dominant species, we can calculate the dominant index. In this case, the dominance index would be 2/3 or 67%, because one of the 3 species is a facultative wetland species and one is an obligate wetland species. However, if there were a 4th dominant species, and species 4 was an upland species, the dominance index would now equal 50%, because 2 of the 4 species would be facultative, facultative wetland, or obligate. In this case, the assessed location would fail the dominance index because the number of wetland-associated species must exceed 50%. If the dominance index fails, the next step is to assess the prevalence index. From this example, you get the flavor of the procedure, so I won't go through the prevalence index, except to tell you that all species are assessed in calculating the prevalence index, and in determining if there is a predominance of hydrophytes and that the vegetation parameter is met. Now I will give a general background on hydric soils and describe how one determines if the soil parameter conditions are met. Hydric soils form because gas exchange processes between the soil and atmosphere differ between wetlands and upland ecosystems. In a well-drained soil, the pore spaces surrounding individual soil particles are filled with air and can exchange oxygen and other gases with the atmosphere. When soil is saturated, however, all the soil pores are filled with water, excluding air, and preventing atmospheric oxygen from entering the soil pores. Under these conditions, oxygen cannot easily be replenished in the soil, and this leads to a transition from an oxygen-rich state to an oxygen-poor or anaerobic state. One of the factors that changes when soils undergo sustained periods of saturation is changes in the soil microbial community. In upland ecosystems, soils support a community of bacteria and fungi that decompose the organic debris in the soil. These microbes breathe in oxygen and respire CO2. However, when soils become saturated and oxygen is depleted in the soil, a microbial community arises that is not reliant on oxygen, composed of anaerobic bacteria and other microorganisms. This slows decomposition of organic material, which can accumulate near the surface in frequently or continuously saturated soils. The accumulation of large amounts of organic matter is one way to distinguish a hydric soil from an upland soil. When soils are formed under persistent saturated conditions, peat or muck forms. You can see examples of muck and peat in the soils presented here. Peat, which is more common in California, is composed of partially decomposed herbaceous and woody fragments and ranges in color from reddish brown to black. Another way to differentiate hydric soils from upland soils is by color. The decomposition of organic materials by anaerobic microorganisms results in predictable, long-lasting chemical changes in soils that leave behind an observable chemical signature. It is this signature that wetland delineators look for as a means of identifying the hydric soils indicative of a wetland. Of these, the most common chemical reactions involve iron compounds, which result in soils that are gray to greenish or bluish gray in color or streaked with shades of gray, referred to as glade soils. Under saturated conditions, iron compounds become soluble and can be translocated in the soil, as is observed here. In seasonal wetlands, the repeated cycles of drying, interspersed with periods of saturation, can also cause reddish-brown mottling or spotting within the soil matrix, a process akin to rust formation. To ultimately decide whether or not soils are hydric, delineators rely on Munsell's color book, which aids in their classification. The holes on this page allow the delineator to compare soil samples to the colors on the page until a match is found. In this way, both the overall soil matrix and any specific characteristics are accurately described. An accompanying pocket guide to hydric soil field indicators is used together with the Munsell color book as a key to interpret whether the soil features found in the field constitute a hydric soil. As with the wetland vegetation parameter, whether or not the criteria for a hydric soil are met is determined on the wetland data form. On the second page of the form is a section for evaluating the soil parameter. The depth of the soil layers and any defining characteristics of the soil matrix and of any models are recorded and essentially keyed out in the book of hydric soil field indicators to determine if any of the field indicators apply. Listed here are some of the examples of field indicators indicative of a hydric soil. Lastly, there is the hydrology parameter. This parameter can be the hardest parameter to assess because depending on the time of year and also depending on the year, there may be no evidence of standing water or soil saturation present at a given site. For this reason, the Commission has frequently required delineators to revisit a site during wetter portions of the year if they visit a site in summer or early fall, and if vegetation is not present because of human alteration of the landscape or because plants have died and are unidentifiable during the summer drought. However, depending on the site, wetland delineators can sometimes look for for landscape clues to inform them of the presence of water during portions of the year. Some common clues include soil cracking that results from intermittent wetting and drying cycles in soils with high clay content, algal mats left behind after water recedes, piles of debris transported by flowing water, or mima mound formations, a type of landscape topography that is commonly associated with vernal pools. Additional evidence of hydrological dynamics can be gleaned from the presence of a water table near to the surface or from evidence of an oxidized rhizosphere. Reddish streaks in soil along tracks left behind by plant roots are another field indicator of hydrology. The area directly around each root is the area where nutrient and oxygen exchange between roots in the bulk soil occurs and is known as the rhizosphere. When oxygen is delivered to the rhizosphere from the root in saturated soils, a rusty hue is imparted to the soil in these locations. Aquatic animals are also frequently wetland indicators. Fairy shrimp skeletons are often good criteria for identifying wetlands. The identification of fairy shrimp cysts or eggs may be as well. Several other animals, including birds, snakes, and amphibians, also rely on wetlands, and their presence may be verified through burrows, egg cases, or molted exoskeletons. On the second sheet of the data form, there's also a space for evaluating if indicators are present to meet the hydrology parameter. With this hydrology parameter, there are both primary and secondary indicators. With primary indicators, only one is needed to meet the hydrology parameter. However, 2 secondary indicators are required. That concludes my discussion of the hydrology parameter. Although the use of these field indicators is generally straightforward, there are situations where it becomes more nuanced. This is where the art of wetland delineation meets the science. An experienced and diligent delineator will look behind the first blush indicators to get to the deeper truth. In atypical situations where human activities such as farming remove the vegetation, wetland indicator species may be lacking. In order to make a determination, soils and hydrology both should be evaluated, historical records consulted, and the vegetation in nearby similar areas should be examined. By definition, most wetland indicator species occur in uplands with some probability. Therefore, when delineation is based only on field indicators of vegetation, an upland area may be mistaken for a wetland without further analysis. There is generally little chance of error if there are many species present, especially if the species include several wetland indicator classes and are reasonably abundant. However, if there are only a few species present and none are wetland obligate, the wetland vegetation indicator may be less reliable. Where this pattern exists, all other pertinent data must be considered when making a determination. The Corps' manual also includes provisions for adjusting the size of the sample plot based on site conditions and professional judgment. As mentioned earlier, the time at which the delineation is conducted may also affect the reliability of field indicators. In California, seasonal wetlands may have different community composition during the late winter and spring than in the dry summer and fall when upland species may predominate. Although the remains of wetland plants may still be apparent at the end of the dry season, delineations conducted at that time are more difficult and often less accurate. The field indicator for vegetation may also be less reliable in disturbed areas that have undergone fire, recent vegetation clearance, or prolonged drought. Following disturbance, the species that colonize a newly opened patch of land are initially free from competitors, and the relative number of wetland indicator species and upland species may simply be a matter of chance, or may be a reflection of the rainfall patterns in the previous year or two. For example, if there are several drought years following a disturbance, the area may initially be dominated by upland plants, and only after wetter conditions return will wetland species be able to outcompete and replace them. Wetland delineators must be particularly mindful of these situations and make use of all the available data. The term problem area is a technical term of art referring to wetland types in which wetland indicators of one or more parameters may be periodically lacking due to normal, seasonal, or annual variations in environmental conditions that result from causes other than human activities or catastrophic natural events. Historically, the Commission has taken a more protective approach in making its wetland determinations in such areas. In most cases, the Commission presumes that plants that are listed as obligate, facultative wetland, or facultative are growing as hydrophytes, and that the predominance of wetland indicator species is presumptive evidence that the area in which they are growing is a wetland. However, in recognition of the fact that field indicators are occasionally not dispositive, the wetland presumption may be rebuttable by compelling evidence of upland conditions. This is a high hurdle. Evidence of upland conditions is not simply the absence of field indicators of hydrology or hydric soils. Factors that could reasonably be considered include landscape position, topography, soil texture and permeability, presence or absence of a shallow confining layer, rainfall records, well data, photographic evidence of inundation, history of alterations to the site, and especially soil wetness following significant rainfall. For example, if during a normal or unusually wet rainy season, a questionable area is not saturated or inundated for at least 7 continuous days, this is evidence of upland rather than wetland conditions. Quantitative comparisons between the questionable site and nearby known wetland and uplands are also useful. This is not a new way of dealing with problem sites. The Commission employed this approach in its decision regarding wetlands adjacent to Highway 90 near Bayona in Los Angeles. At the Highway 90 site, an asphalt parking lot was decommissioned and the asphalt removed. The subsequent winter was unusually wet, but there was no biological observations made at the time. The next year was a drought year. Nevertheless, large portions of the site had a predominance of wetland indicator species that had colonized the newly opened area at a time of unusually wet conditions. Of the 8 dominant herbaceous species present in the samples, 6 were facultative upland or upland. However, the remaining 2 were sand spurry, an obligate annual herb, and rabbit's foot grass, a facultative wetland annual grass. Sandspray occurred throughout the site and particularly dominated the apparently drier regions higher along the slope. However, outside of sandspray patches were 30 species of mostly weedy upland plants. Given the existing conditions, located on a slope, extremely low rainfall, and the permeable nature of the surface soils, staff concluded and the Commission concurred that the asphalt removal had opened this area and that the colonization by wetland species had happened under unusually wet conditions and not because the area was a wetland. After this decision, the Commission was sued and the Commission's decision was upheld by the trial court. Another permit that brought up important issues relating to wetland protection was an application to add 8,700 cubic yards of fill to a wetland and to build a horse stable in the city of Encinitas. Here's a closer look at the piece of land in question from a Google Earth snapshot in 1994, a couple of years before the permit application. As you can see, this property lies quite close to Escondido Creek, with another ephemeral creek running right through the property during some years. The sequence of events of this project are as follows. This permit was approved by the county with conditions despite several confounding characteristics, which are its status as a wetland, its location just north of the San Elijo Lagoon, and its position within the 100-year floodplain of Escondido Creek. The project was appealed to the Coastal Commission, where it was unanimously denied. The applicants then appealed the case on the grounds that the wetland was degraded and therefore did not warrant wetland protection. However, the Commission's decision was eventually upheld by the Court of Appeals, which concluded that all wetlands, even degraded wetlands, are guaranteed protection under the Coastal Act, especially in light of the history of vast wetland destruction in California. They further argued that this wetland provided important buffer protection to Escondido Creek and to San Elijo Lagoon. These principles have subsequently been affirmed by many subsequent commission decisions. That concludes my presentation, and I thank you, and I can answer any questions.
Next, we're going to have a presentation from Aaron Chalmers, an attorney in our legal division, who will be addressing the regulatory and legal issues associated with wetlands. So take it away, Aaron.
Good morning. Thank you, Dr. Coteen. That was an informative presentation. I learned that the word muck is actually a scientific term. So, as well as the fact that delineating wetlands is a very fact and site-specific inquiry. So, as Mr. Ainsworth said, I'll follow up to describe the legal context for regulating wetlands under the Coastal Act. And as Dr. Coteen said, excuse me for a second. Could I have that? Does that work here? Just this one? Okay. As described by Dr. Coteen, the Coastal Act's definition of wetlands is quite broad, and broader, in fact, than some other agencies' definition of wetlands, such as the Army Corps of Engineers. And courts have repeatedly upheld the Coastal Act's broad definition of wetlands, relying not only on the definition found in the statute itself, but also the definition found in the Commission's regulations, as well as some guidelines that the Commission put out back in 1981. In addition to these definitions, LCPs may have slightly different definitions of wetlands and slightly different regulation of wetlands. Although LCPs are not allowed to have less protective definitions, they may have more protective definitions. Now, designating an area as a wetland under the Coastal Act confers specific legal protections. However, while the Coastal Act does strongly protect wetlands, it does not prohibit all development or all use of wetlands. On the contrary, it actually allows some uses and even encourages some beneficial uses of wetlands. But to balance these somewhat contradictory goals, although the Coastal Act allows some filling of wetlands, it's only in very specific circumstances. And the three main criteria governing when wetlands may be filled, diked, or dredged are found in Coastal Act Section 30233. First, wetlands may only be filled, dredged, or diked in order to facilitate certain enumerated uses. Second, even those uses are only allowed if there's no feasible, less environmentally damaging alternative. And third, to the extent there are any impacts to the wetlands, those impacts must be fully mitigated. And I'll address each of these requirements in turn. As to the first requirement, the Coastal Act only allows certain uses of wetlands, and this includes for coastal-dependent industry, boating-related facilities, incidental public service facilities, such as the laying or maintenance of pipelines, some mineral extraction, restoration, nature study, and aquaculture. Additionally, the Act requires even greater protection of and allows even fewer uses in 19 specific wetlands that have been identified by the Department of Fish and Wildlife as especially valuable. And crucially, projects that involve non-designated uses of wetlands are simply not allowed in the wetlands, regardless of whether or not there may be mitigation. In the case Bolsa Chica Land Trust versus Superior Court, the court specifically held that residential development is not an allowed use of wetlands, regardless of the fact that in that case there was going to be mitigation that would supposedly fully mitigate the wetland impacts, and that the development would be used to help fund other wetland restoration. Next, even if a project involving wetland fill qualifies as an allowed use, it will still only be allowed if there's no feasible, less environmentally damaging alternative. And this requires an applicant or a reviewing jurisdiction to analyze feasible project alternatives that will have fewer wetland impacts, both in terms of the acreage impacted as well as in terms of the actual wetland function. The reviewing jurisdiction or the commission then analyzes each alternative to see which one has the fewest impacts. Although an applicant or local jurisdiction is supposed to develop and consider these alternatives on their own, The Commission may also develop and consider alternatives on its own if they fail to do this. And courts have upheld the Commission's denial of projects in cases where the Commission determined that there did appear to be a less damaging, feasible alternative. For example, in the case City of Chula Vista versus Superior Court, the court held that the Commission properly denied a proposed plan to build a road through wetlands, in part because the Commission identified a potentially viable alternative route that would access requested development without going through wetlands. The third requirement is that any impacts to wetlands must be mitigated to the extent feasible. At a minimum, mitigation must ensure no net loss of wetland acreage or function. As a practical matter, the Commission generally requires a 4-to-1 ratio of restored wetlands to impacted wetlands. And this higher ratio accounts for the fact that there is always some temporal loss of wetlands during the time when restoration is taking place, as well as the fact that restoration is an imperfect science and does not always result in the perfect recreation of wetland functions. And in fact, because wetland creation and restoration are tricky, and wetland restoration is only often partly successful, the Commission emphasizes avoidance of impacts and protection of existing wetlands as priority mitigation. On the other hand, restoration or payment of in lieu fees should only be approved if those priority mitigations are not feasible. And last, both the Coastal Act as well as the California Environmental Quality Act, or CEQA, require that mitigation measures be structured in a way to ensure that they will occur and will in fact be successful. For example, CEQA does not allow the Commission to adopt mitigation that merely requires a future study which will determine the extent and location of required mitigation. Rather, the mitigation measures must describe who will undertake the mitigation, how it will be carried out, where it will be carried out, as well as what standards will govern the mitigation. For example, what acreage of mitigation or what acreage of wetlands will actually be restored or recreated, as well as what monitoring will be carried out to ensure that the restoration is successful. Now, the fact is that not all wetlands are equally pristine or equally valuable for wildlife. And project applicants, as Dr. Coteen mentioned, sometimes raise this point and argue that certain wetlands on their project site should not be entitled to the full protection or do not deserve the full protection of the Coastal Act. But as Dr. Coteen also mentioned, the law is very clear that all wetlands are protected equally under the Coastal Act, regardless of their condition. And courts have repeatedly rejected arguments that the Coastal Act allows degraded wetlands to receive lesser protection. And once again, as Dr. Coteen mentioned, the case Krakorowitz versus Coastal Commission is on point here. There, an applicant wished to construct horse stables and related improvements in a seasonally wet area that had been used as horse pasture and that the applicant described as marginal degraded wetlands. The court, however, upheld the Commission's determination that the area met the Coastal Act's definition of wetlands and thus was entitled to full protection. The court stated that the Coastal Act does not distinguish between wetlands according to their quality, and that the quality of the wetlands is, quote unquote, essentially legally irrelevant. Courts have also described why it's important to protect lower quality wetlands. First, as we all know, wetlands in California have a long history of being destroyed, and we only have left a small remnant, and it's very important to protect what we have left. Second, lower quality wetlands in some cases help buffer surrounding higher quality wetlands and are important for that reason. And third, courts have described how if all wetlands were not protected equally, it would, quote, encourage developers to find threats and hazards to all wetlands located in economically inconvenient locations. And that's from the Krakorowitz case. Next, like degraded wetlands, artificially created wetlands also generally receive full protection under the Coastal Act. Courts have noted that the U.S. Fish and Wildlife Service's definition of wetlands specifically contemplates that wetlands may develop artificially as a result of excavation. There is, however, a narrow exception for wetlands that are created if floodwaters wash away a section of previously dry land, thereby creating new wetlands. And in those cases, landowners actually do have a legal right to reclaim those lands within a certain short period of time, notwithstanding the Coastal Act's otherwise applicable restrictions on filling wetlands. In addition to Section 30233's protection for wetlands, wetlands are also frequently considered environmentally sensitive habitat area, or ESHA, because they commonly provide habitat for species of concern. Regulation of development in ESHA is generally governed by Section 30240 of the Coastal Act, and I'll describe that as well as ESHA protections in more detail tomorrow during our ESHA workshop. But importantly for today's discussion, it's important to note that provisions of the Coastal Act governing ESHA and provisions governing wetlands sometimes conflict. For example, the Coastal Act allows more types of uses in wetlands than it does in ESHA. And courts have resolved this apparent discrepancy by holding that the more specific provisions governing wetlands govern wetlands rather than the more general provisions governing ESHA, to the extent that they conflict. However, if a project impacts wetlands in a manner that is not regulated by the ESHA protection provisions, such as draining a wetland as opposed to diking or filling it, the ESHA protections still apply because there is in fact no conflict between the ESHA and the wetlands provisions. Likewise, some ESHA protections may generally not be in conflict with the wetlands provisions and thus should be applied. For example, Section 30240 requires buffer zones around ESHA to protect them from disruption. And this requirement can often be applied around wetland ESHAs as well. And as a matter of practice, the Commission and LCPs generally require buffer zones when there's development near wetlands. And the buffer zones are often anywhere from 25 to 200 feet. So, in conclusion, the Coastal Act contains strong protections for wetlands. It only allows filling, dredging, and diking in very specific circumstances, and even then, only if there's no feasible, less damaging alternative, and if there's full mitigation. That concludes our presentation, and I believe we had set aside time in case the commissioners had any questions.
Thank you. I'm sure that there will be some questions and comments, so I'll begin with Commissioner Mitchell.
I just wanted to say thank you very much for that staff report. That was very interesting, a lot of great information, and very helpful in kind of our being able to sort of weigh all of these as we look at items. I had a couple of questions. One is the staff report that you guys gave in the narrative. It's not in our packets. We didn't get a staff report on this, or is the...
No, we did not prepare a written staff report on this. This was the presentation today.
Okay, so, okay. Well, just, I think it might be helpful to have you know, that in writing so we can go back and review. I think it was really good and very helpful. So I don't know if that's possible, but I had a couple of questions. Dr. Coteen, you said intact versus not intact wetlands and their buffering. Can you explain that to me? This was early on in your presentation. You said intact wetlands provide buffers, non-intact do not. So I'm confused about that.
I was essentially just referring to the quality of the wetland, how well it's functioning. Does it provide the buffering services, ecosystem services? So an intact versus a degraded wetland was all I meant.
Okay, and so do we treat those differently, and is there a different definition when we're looking at that? They're just...
No, we don't treat them differently.
One just is functioning better than
One
the
is
other.
functioning better.
And so this is my question is, wetland restoration, and I understand, and I'm sorry I didn't get your name, the lawyer, but go ahead.
It's Aaron Chalmers.
Aaron, okay. Thanks, Aaron. Restoration of wetlands. Obviously that is possible. I mean, in the Bayona example, we took the pavement out and wetlands were restored, habitat was restored. So this is what I always struggle with. is if there's a degraded wetland that isn't intact and isn't functioning as well, wouldn't we be better off to pay for, have a 4-to-1 mitigation or, whatever ratio we decide to improve the wetlands so that we actually expand wetlands in the state and have more intact, useful wetlands instead of protecting the ones that are somewhat degraded?
Commissioner, we actually do that frequently. The intent is to have no net loss of wetlands.
Right.
Which means a habitat conversion of something into a wetland, which is difficult to do, and in many places there's not a lot of space for it. So this commission in past actions has accepted substantial restoration of very degraded wetlands as mitigation for fill elsewhere. So, for example, the largest wetland restoration that has taken place recently was the San Dieguito wetland that Southern California Edison is restoring as mitigation for impacts of the San Onofre Nuclear Generating Station. Some of that area was degraded wetland that was supported by rainfall, and it was dug out and made tidal, and they got restoration credit for it.
But that's not on site, correct? I mean,
Well,
the San Dieguito is in a different area than
so they were getting mitigation credit for impacts to fishes from marine fishes because wetlands. There is some nexus there because wetlands provides nursery habitat for many marine species. That was a difficult one to figure out.
Right.
Just exactly how do you mitigate for those kind of marine influences. Usually we're dealing with some kind of impacts to a similar kind of wetland. But again, if creation isn't possible, substantial restoration has been approved by this commission.
And what was the ratio of?
4 to 1.
It was 4-to-1. Because I'm sensitive to the concept that Aaron put out, which is, wetlands in an inconvenient economic area are then, mitigation is done in a different region or a different area because, we want to build a house here because it's right on the bluff and it's, more desirable for property values, but we're going to mitigate in some area that isn't sufficient. So I just,
the point there, I think, Commissioner, is that simply doesn't happen.
Right, but we were seeing the San Dieguito and the Songs plant, that was in a different area. That's what I'm just trying to understand.
Maybe you should address that.
I mean, I appreciate, I'm not questioning what we did in the songs. That's not the issue. I guess I'm just looking at it of how we balance that, to get more intact, useful wetlands versus just looking at the degraded wetlands.
Well, the degraded wetland cannot be filled and mitigated elsewhere.
Okay, so I'm sorry. Maybe I'm just not following this.
If I may, correct me if I'm misunderstanding your comments. Are you asking about a situation where somebody is proposing a use that isn't one of the listed allowable uses in a wetland? And if they're, so for example, residential development is not one of the allowable uses within a wetland, but if an applicant is saying, well, if I build a house here and these are degraded wetlands, I'm willing to provide this really wonderful mitigation package. Is that what you're asking me about? What
Yeah,
the
I'm just
ability is to approve
looking
this?
at the policy implications of protecting the degraded versus getting restoration of more intact.
Yes. Well,
wetlands.
as the courts have interpreted Section 30233, especially under the Kirkorowitz case, yeah, the same protections apply to, vibrant, well-functioning wetlands versus severely degraded wetlands. Now, there can be certain circumstances where the commission can approve development in wetlands that is inconsistent with 30233 if, that is necessary in order to avoid a taking, and there isn't any kind of alternative development available in order to avoid a taking of that property. That would be one situation where the commission could approve development even though it's inconsistent with 30233. There could also be some circumstances where the denial of a development because of impacts to wetlands would itself be inconsistent with some other coastal act mandate. In that situation, the commission is addressing a conflict between different Chapter 3 policies, and then the commission can evaluate, well, what approach is on balance most protective of significant coastal resources? And in a situation such as that, the commission, depending on the evidence before it, might be able to decide, okay, there's a conflict here, and the most protective approach would be to allow the fill of wetlands in order to address whatever the other coastal act concern is and require good mitigation for the fill that does occur.
So we can and have in the past allowed for degraded wetlands if it's one of the allowable uses, if there's a conflict, or if it's a takings.
That's correct.
Okay. That gives me some clarity. Thank you.
Thank you. Vice Chair Bochco and then Commissioner Luevano.
Thank you, yes. And again, that was a terrific presentation and I think clarified a lot of issues that we've touched upon in many cases, but sometimes weren't really clear on, why things were treated the way they were. But for me, I'm beginning to understand degraded wetlands, but I'm assuming when we say it's degraded, it was something that existed prior to degradation. So, in other words, a wetland existed, and then it was degraded by either human activity or something else. Is that a fair definition of degraded?
I would say not necessarily, in that one point I was making is that wetlands could have been, what I'll say, artificially created over time by prior excavation. Let's say an applicant.
So that's my next question.
Okay.
That's human-created wetlands, correct? What you're saying?
Correct.
Okay.
I'm calling them
that
different
is my
things,
next question. So let me just ask that once. So yes, okay, on the degraded part, and as to the human-created wetlands, are you saying that there was never a wetland there before? It doesn't have that hydrological soil from undisturbed environment, but because of human activity, for instance, dredging or tractor trailer wheels, something created a trench in which water collects when there is water, that would be considered a wetland because what?
It might be considered a wetland.
Well, let's say you're going to consider a wetland. What would make that a wetland where there was no wetland before? That's my question.
Right, good question. So it goes back to the definition of wetlands, which Dr. Coteen went through. If it has hydric soils, if it has hydrophytic vegetation, or if it has hydrology, it's a wetlands, whether or not it was quote unquote artificially created or whether it was created by nature over hundreds or thousands of years. And it's not just a puddle. I mean, it has to have been there long enough to have developed one of those characteristics.
Okay.
So if it rains and there's a puddle, go ahead, sorry.
Believe me, I don't need a long explanation.
Yep.
I just need a short one. Because what I'm looking at is certainly something has been created over a long period of time where nature has taken over. I can understand. I mean, we have changed nature and yet it accommodates us and it will keep growing back. What I don't quite get, and it goes to your puddle analogy, is how something over a short period of time, let's say 20, 30 years. I mean, that's not really, again, I'm not a scientist, but it seems to me that wouldn't be something that we were looking to preserve since it would never have existed before anyway. Because I know the law is looking to save wetlands because they're diminished and we've taken them away. It doesn't seem to me like the law is looking to change a modern human wetland of a very short duration to create more wetlands than nature would have provided on its own. Does that make any sense? Let me talk to the
I
scientist.
think I
Can I
understand.
talk to the scientist for a minute? I'm so
Yes,
sorry, I don't mean to
in
be
terms of
rude.
the law, I'll briefly address that and
Yeah.
then let Dr. Cotin. In terms of the law, it actually does not make a difference, and there are court cases saying that where there has been excavation and then some period of time, a decade, let's say, passes, it turns into a wetland, 10 or 20 years is a long time for,
Is
well,
it?
now I'm getting out of my depth here. But in terms of the law, it does not make a difference.
Doctor, anybody?
Does that satisfy your question?
No, it doesn't. Because it seems to me that we're talking about two very different things. One is provided by nature over a long period of time. In other words, it existed before the human population
yeah.
destroyed it. And the other one exists because humans are busy doing what humans do, and then all of a sudden we have something that wasn't there before. And I guess it goes to duration. I mean, like you said, you think 20 years is a long time. In science, it's not a very long time.
I mean, nature is dynamic and the landscape is always changing.
I understand that.
Yeah. So.
But if there was no wetland before, I guess I'm just struggling with that concept. We're trying to preserve what was there. And then we come in and we disturb, let's say, a very dry piece of property. And over time, we actually have some rain at some point, and it gets wet. It doesn't have those things you're talking. It doesn't have groundwater close up. It doesn't have, maybe some of the plants grew because it happened to have some water for a while. It just seems a very different concept to me than the natural wetland. And I'm not going to let this go because obviously we have a disagreement of opinion, but I'm struggling with that. It just doesn't seem the same to me. So
Yeah.
I'll let it go.
Okay, John.
Commissioner, I might just give you a couple of examples. At a prior oil field north of Goleta, near the coast, they had some containment facilities. The tanks were removed and the berms were left, and it became a wetland.
I'm sorry, everybody's talking. I'm sorry. No, it's okay. Did you get?
It became a wetland. As a matter of fact, in that case, in about 30 years, it actually developed hydric soils. Another case is a case in Orange County called Hillside Village South, where they started some construction and then stopped, but they left a depression, and it became a wetland that was protected by the Coastal Commission. And in Marina del Rey, there's a similar situation where they began a construction, it was abandoned, and the area became a wetland. Now, in that case, it's a little more complicated because originally it was a tidal wetland.
Exactly. That's my point. So I can see that, the law has supported that definition. It's just somehow, it just seems like a different condition to me. So for instance, if somebody has been using the land for a very long time and because of that there's some trenches and things, it's just hard to understand how it become a wetland if it never was before. Doesn't it have something to do with groundwater? It just seems like you can't be in a wetland if you don't have any groundwater to support it.
Well, in order for it to be a wetland for the Commission's consideration, it has to meet the definition.
Okay. Well, thank you. I appreciate it.
Commissioner Mitchell, did you want to follow on that particular point?
Yes,
Before
I just had a
Commissioner
really quick
Lueven?
follow-up.
I understand. No, just on this point.
So on that very point and that was, I guess, the point I was trying to make is, wouldn't biologically we be better off to, instead of protecting a man-made ditch that became a wetland, to then, instead of protecting that, to actually require mitigation to create an intact, strong wetland that we can restore? Do you know what I'm saying? Because that's the issue, is that this man-made ditch that's been around for 15 years or 30 years versus an area where a wetland is gone, but would have been a natural wetland, long ago, and do mitigation relative to that. It seems like that would increase the amount of wetlands we have and strong wetlands versus protecting a indentation made by a tractor, which is kind of the case. And I understand that the law, is supporting that. It just seems from a policy perspective that would be, better for the wetlands in the state and to restore the historic degradation.
Did you want a response?
I think if you wanted to reiterate, Dr. Dixon, what you and the attorneys have been saying.
It is certainly, first off, I don't think we deal very often with a wetland caused by traffic. But we certainly do deal with degraded wetlands, oftentimes relatively small ones. And one could certainly argue that it would be better to have a great wetland someplace else. You could also argue that you should turn that into a great wetland. It's going to be a very site-specific determination, but legally it appears to be moot.
Commissioner Luevano, then Commissioner Cox.
Thank you, Chair Kinsey, and thank you to the staff for a great report. I'd love to continue this discussion at future meetings and continue to hear more from you on this topic. But I have a question, actually two questions. Maybe it's just a two-pronged question. I don't remember which one of you said that the goal was or the intent, the policy intent was no net loss of wetlands. And I'm just wondering what the baseline on which that goal is based is, what's the number that you're using to determine whether there's a net loss or gain? And I guess the second part of that is, rather than a goal of no net loss, has there ever been a goal of a net gain considered?
Well, the no net loss was both a federal goal and a goal determined by the governor, prior governor. And the way it's determined is not by totting up all the wetlands we have, which we don't know, but looking at a particular area and saying, as a result of these activities, are you going to have fewer wetlands here than you otherwise would, which basically means, are you going to fill a wetland? And if you do fill a wetland, are you going to create a wetland elsewhere? The fact of the matter is, we generally do have a loss of wetland.
Mm-hmm. So the second part of my question is, has a goal of any net gain ever been considered? Or is that something that would have to be done at the federal level?
I'll address that briefly.
Okay.
There are actually a couple sections of the Coastal Act that discuss not only that projects have to maintain wetlands, but in fact that they should enhance wetlands. So it's either maintenance or enhancement. So I think it's definitely a fair reading of the Coastal Act that it requires, at a very bare minimum, maintenance of whatever we have at the time a project goes forward, but also with the goal that it should be enhanced or expanded.
Okay.
Commissioner Cox, then Commissioner Schallenberg.
Again, I want to add my kudos to staff for a very good presentation, and I would just, maybe if we could get copies of the PowerPoints and other information, it'd be nice to have it just as kind of a reference point. I just want to go back for a second in regards to the, I think you referred to it as a 1-parameter wetland and a 3-parameter wetland, and get a better understanding of what agencies follow which parameters. My understanding, the Coastal Commission and the Army Corps of Engineers focus on the 3-parameter wetlands, and U.S. Fish and Wildlife Service, as I understand it, is focused more on the 1.
The U.S. Army Corps of Engineers is a 3-parameter wetland definition, and the Coastal Commission, the U.S. Fish and Wildlife Service, and the California Department of Fish and Wildlife all consider a 1-parameter wetland definition.
Coastal Commission.
Coastal Commission is 1 parameter.
And why, I understand different governmental agencies take different positions, but wouldn't it be easier if everybody agreed on what a wetland is?
It might be.
I guess that's more of a rhetorical question. And I guess this would be like a question you'd find on SAT test or ACT test. Is it safe to say that all wetlands are ESHA, but not all ESHA is wetland?
All wetlands are not ESHA. Only wetlands that support species of special concern, usually. John has a different. Not all wetlands are ESHA.
In many LCPs, all wetlands are considered ESHA. And in the 1981 guidelines that were the basis of assisting governments to create their LCPs, that is the case. In terms of our recommendations to the Commission, it is very difficult to call some very degraded wetlands ESHA. And most of the time, the issue simply doesn't come up because the wetland gets analyzed under 30233. But I would say that intact wetlands generally should be considered ESHA.
And I guess the reason for my original question was I was just thinking back when we were dealing with the Bernardo Shores project in Imperial Beach. There was the city of Imperial Beach was trying to put in a bicycle path that Fish and Wildlife Service came to the conclusion that as I recall, it was a minimal impact on a wetland and they could mitigate it. And the commission staff had recommended that the bike path not go in because it was going to, there was a different interpretation in regards to the impact on the wetland. Does any of that ring a bell, or?
In that case, we were looking at what is the least damaging alternative. And so moving it out of the wetland, that was an alternative there, and that's the one that we were recommending.
But I think in that instance, Fish and Wildlife Service came to one conclusion that it was okay because it was going to be mitigated, but our staff came to a different conclusion, and I guess that's something we just have to deal with, right? As a commission.
We're looking at this under the Coastal Act, and that is the standard, is the least damaging alternative, as Aaron had mentioned.
Yeah, just to reiterate that U.S. Fish and Wildlife or Army Corps may be looking at this through a different lens because, of course, they're implementing different laws than we are.
Okay. All right, thank you.
Commissioner Schallenberger, and I'd like to make a few comments.
Thank you. Thank you, Chair Kinsey. If I could, excuse me, I don't think I've talked enough this morning. Aaron, could you said something and I just missed it about a court that had made a ruling on something to do with economically inconvenient places. And I heard that phrase, but I missed the context.
Sure. That was the Korowitz case, which both of us discussed somewhat, and the context there was describing why the Coastal Act protects wetlands in place. And the quote, well, again, the context was, why is it important to protect all wetlands, including potentially degraded wetlands? And one reason that the court gave was that if that's not the case, then we would always be having applicants or whoever wants to build a project coming forward. And the court said it would encourage developers to find threats and hazards to all wetlands located in economically inconvenient locations. Does that answer your
It does,
question?
thank you. And I think that's important because that's precisely what we cannot do, is be looking for places to create wetlands or enhance wetlands or expand wetlands just because where a project is going, it's economically inconvenient to have a wetlands there. So I just want to thank you very much. I think the report was great. We should almost have a workshop like this every 2 years, just to remind us that the definition of wetlands and how we treat them is not a matter of opinion. It's based in science and it's based in law. And to Commissioner Bochco's point, it strikes me that what I'm hearing the law is saying, and courts have upheld, is it doesn't matter why it's a wetland, it only matters if it is a wetland. It's a very different way of looking at it than what caused it. And for me, that makes it quite a bit simpler. That's what the courts have said, and so that's our job to uphold. So I just thank you very much. I think it was a very good presentation, and I think putting the slides up on our web will be helpful for everybody. Thank you.
Thank you. Commissioner Turnbull Sanders, then Commissioner Mitchell.
Thank you. Thank you, staff, for an excellent presentation. I was just hoping that maybe we could add to these slides a list of the legal authority. I think that that was discussed about when certain wetlands are also created by man-made activities, or whether it's something that's degraded before the wetlands is created, or something that happens when the degradation occurs after the natural existing wetlands are there. But I think there was a discussion about a line of cases that held that degraded wetlands could also be deemed wetlands. And I was wondering if it's possible for us to get a line of legal cases holding that degraded wetlands are also wetlands, specifically those that are created by man-made processes. And I think the Korowitz case was cited, but I was hoping to get a little bit more in terms of legal authority on that.
Sure, we'd be happy to do that. I originally had all of these beautiful citations in my slides, and I was told that it was too many words. So I took them out, but I'd be happy to provide those to you.
Thank you.
Commissioner Mitchell.
And my only follow-up question is, the regulations for wetlands, when did we develop those? When did the commission develop the regulations?
Let me look.
Okay, great.
I believe it was in the 1970s, but I'll double check right now.
And we haven't revised the regulation based on case law, or it's just been consistent with the case law that has come
There are a couple
forward?
different things. There are the actual regulations, which Chris is looking at the dates for right now. There's also the 1981 interpretive guidelines that we put out, and those were updated, I believe, in 1990 to take into account some of the case law that had come forth, at least by that point. The Commission also put out some guidance in 1994 because under the Federal Coastal Zone Management Act, we were required to clarify some things, so there is separate guidance, which I didn't even get into.
So, and a question, the difference between guidance and regulations legally?
Legally, obviously, the statute controls first. The regulations are also law, and so applicants and the Commission is bound by those. The Coastal Commission is somewhat unique in that it is also allowed to put out these statewide interpretive guidelines, which are, correct me if I'm wrong, Chris, they're not binding law, but courts will certainly look at them with a lot of deference and will assume that they are correct unless the court finds that they are, just clearly unauthorized by the law. So it is guidelines, but we generally treat them as what we're doing unless a court overturns it.
So, but our guidelines are simply a document that we put together, and does the commission vote on guidelines?
Yes.
Okay.
Yes.
But it doesn't go through the Office of Administrative Law process review for legality that a regulation goes through?
That's correct. The Coastal Act expressly authorizes the commission to adopt guidelines without going through that formal OAL process to provide assistance to applicants and local governments in terms of how to implement Coastal Act requirements, either prior to the adoption of LCPs or when considering amendments to LCPs. And just going back to your earlier question about when the regulations were adopted, it looks like the current version of the regulations with the wetlands definition was promulgated in 1983. What I don't know for sure off the top of my head is if there was a substantially similar definition to the regulations prior to that, but certainly the current version dates back at least that far.
And what's the advantage or perspective of going through, putting out guidelines versus a regulation? besides, it doesn't have to go through Office of Administrative Law?
Well, the Coastal Act authorizes either approach. The process for adopting guidelines is a simpler process. You know, the commission needs to hold a public hearing, provide opportunities for public input, but it's not subject to the same more detailed requirements regarding the formal adoption of regulations, which also have to be submitted for review and approval by the Office of Administrative Law. Regulations, once they're formally adopted, have the status of law, and as Aaron stated previously, the guidelines don't have that same high legal status, but the courts have given a great deal of weight to those guidelines.
Great, thank you. No more questions, I promise.
Commissioner McClure. Commissioner McClure.
I was, because of the breach of our security line here, but I have a question in relationship to the indicators, where we have one indicator as opposed to the Army Corps of Engineer having 3.
Other way around.
And is that by statute or is that by policy?
So it's actually the parameters. It's a parameter definition, and the parameters are the hydrology, vegetation, and soils parameters, and the indicators support identification of the parameters.
So I'm just asking, our interpretation where we declare a wetland, if there's one parameter present?
It's in the commission regulations.
Okay, so it is a
one parameter.
regulation,
Mhm.
it's not a policy.
Right.
And then I have a question in relationship to the field analysis. What kind of process do we go through when we look at the soil in order to determine the indicator?
So normally what happens is we get a wetland delineation report from the applicants, and we review their report.
And do we require a certain standard of that? Like, do they have to dig a certain hole and be, so many inches deep and so far away from the upland and that kind of, is that a requirement?
So the standards are provided by the manual, and the procedure is standardized.
Okay,
Yeah.
and I want to thank you for the report, and I too would like to see the PowerPoint, but I would also like the text, because I'm much better at being able to read things and digest them and read them again, and so that would be much appreciated. Thank you.
And we'll do that. We'll put that up online.
Thank you. I too appreciate this. I think it was an outstanding report, and I think the questions that the commission have raised, I think only tend to create a very clear understanding that there really are very limited purposes, and they're defined in that section 30233 as to when activities can occur within a wetland. One thing I wanted to confirm about that is agricultural grazing, would that be a resource-dependent use that would be permitted in a wetland?
I'll let Chris address this in some detail, but first, there are exceptions for agriculture in wetlands, such as, I suppose, rice farming. Some of those are allowed. I don't know about grazing.
I would just point out, we don't need to get into the details today, but I would say that it was an omission not to address the agricultural considerations associated with wetlands, because agricultural lands, pasture grazing is a resource-dependent requirement. These occur on ranch lands where wetlands exist, and I think it will be important, if not now, at some point, for the staff to really help us understand at the same level where agricultural activities bump up against our wetland policies and regulations.
Sure. I'll mention one other thing, which is the Kirkorowitz case was about horse grazing at least, and so that was grazing land, although it wasn't agriculture probably.
No.
The fact of the matter is that both grazing and crop-style agriculture does occur in wetlands. But the fill of wetlands is not allowed as part of those activities.
So I would just ask, I think a clarification would be useful for us as to where that line occurs in agricultural areas. The other question I had to do with the buffer. The Coastal Act doesn't specifically define a buffer, so how are we establishing the buffer from wetlands?
So the LCPs address the buffer distance from a wetland.
So in the areas where we don't have an LCP approved, how do we establish the buffer?
Generally speaking, the commission has established a 100-foot buffer, and it has become somewhat of a default, but there are good reasons for these buffers. And so, for example, there have been studies done to show that within 100 feet, most sediments drop out. And so, now that depends somewhat on slope and so on, but the 100-foot seems to be, generally speaking, the minimal distance that will protect the water quality of the wetlands, and also is sufficient to protect much of the wildlife. But the commission has required larger buffers under certain circumstances, especially in large, pristine wetlands that support, generally speaking, birds, and have allowed smaller buffers around more degraded or smaller wetlands that don't seem to require that level of protection for the functions they provide. So we tend to try and look on a site-specific basis in each case, but the fact of the matter is probably the most common buffer that this commission has required is 100 feet.
Thank you. Very good. Well, thank you. We don't have any public speaking cards on this, so I think this completes this item, and we'll take a 10-minute break, and then we'll continue with the commission's work.